So here's what we're going to do. We're going to talk about the linear programming. Okay, can someone remind me where we ended last time? I think in short, I will write LP. Why? Because I think we were in the middle of this problem, linear programming again and again and again. So what is a linear programming? Well, it's a specific kind of optimization problem. Okay, so you have there is an entire area which is called optimization. Last time we were looking at this example. Optimization. So I have the integral from -1 to problems. 1 over actually 4 dx. The integrand linear programming is a kind of optimization problem. A point this area is interesting because several different people from several different areas, they work in this area. And if you look at the graph of 1 over actually 4, it will be the same looking as the graph of 1 over x
control theory, for example.
They also, the graph of 1 over x squared,
operation
1 over actually 4 will look the same.
If you don't know that, just use your calculator and see
so
the graph will look like what I have there. My scale is of course bad.
So let me show you what kind of optimization problem we're looking at. So generally speaking,
at 0 you have an
generally speaking, in an optimization problem, you have certain quantity. I'm going to call that z.
If I integrate, I am trying to see whether the region
is certain function. Let's call that f of x.
Whether that region has finite area or not, right?
Where so f of x, where x can be, let's say,
then we know
a
that
vector
the area below the graph above the interval
so
from
x1 to xn are
finite
variables.
area. Otherwise,
and so let's say you're trying to maximize this function.
If I have a point in the middle of the interval where I have a discontinuity, what's the definition of the integral?
There are certain constraints.
So we break it up at that point. So we break up the integral from -1 to 0 and 0 to 2. And what's the definition when I have a discontinuity at the right?
The constraints will be like maybe like f1 of x
if I have a discontinuity at the upper limit,
is less than or equal to b1.
And then I take the limit as t goes to the upper limit from the left side of the upper limit, right?
K of x
upper limit, lower limit, so you approach to the upper limit from the left.
Bk.
You approach to the lower limit from the left. Right.
Something like this.
If I have a discontinuity at the upper limit, replace the upper limit by a parameter t, and then take the limit as t goes to the upper limit
of
from the
optimization problems.
For the second integral, I have a discontinuity at the lower limit. Replace that by a parameter
we're
s.
going to be actually looking at
And then take the limit as s goes to 0.
Functions involved
the lower limit
from
the right. Okay.
So that's what we did so far. You see the function f of x, and now each f1, f2 functions. See what we get. They could be all linear functions, or they have this is equal
some
to
other functions.
If they are all linear functions, then it's a linear programming problem. T goes to 0. If at least one of them is not linear, then we have a non-linear programming. Someone please tell me what the antiderivative of 1 over x to the 4 is. So which is -1 over. So let me give you an example of a linear program. So I'm going to get the limit s going to 0. Example of it in the right. You want to same thing, maximize 3x cubed. The quantity z s right here, which is 3 x1. Let me just show for everybody that my integrand is basically x to the -4, right? And my integrand is negative x to the 4. you maximize this quantity with
if I take the
certain
antiderivative, then
so
I would be getting what? 1 over negative 4 plus 1.
The following
Actually, negative 4 plus 1, which would be
x1
over negative 3
is less than or equal
negative
to 4,
3.
let's say.
And this quantity
let's say,
is the same as negative 1 divided by 3x cubed,
less
right?
than or equal to 4.
You see that?
And let's say 2x2 is less than or equal to 12. And
you don't see that I should be going to Mars or some other place, right?
x1 plus
so here's
x2
here's what's going to happen then.
To
I take the limit
18
as t
and also
goes to 0 from the left.
x1 is
I plug
larger
in
than
t
0.
and I plug in
x2
negative 1, right? So if I
than
plug in
0.
t, what do I get? Negative 1 over 3t. So cubed. This problem is asking I plug in negative 1, I get what?
The quantity z. The function
Positive
z.
1/3, right? Very good. So because when you plug in negative 1, you get negative 1 over negative 3, right?
Am I making sense?
Same thing here. So these constraints that I have,
goes
there
to
are 2 variables,
right?
x1 and x2. So what are
Plug
the
in
pairs
negative 1
pairs of
over
values of x1 and
2
x2?
cubed 8, 24.
Geometrically, how do we
Minus
represent pairs
-1
of
over
values of x1 and
s
x2?
cubed.
A plane. x1 axis, x2
So
axis.
far, okay.
And pairs of values of x1
okay?
and x2 are given by the points, right?
All right.
So these constraints,
Now,
they
somebody tell
define
me
a
what's the
subset
limit?
of the plane, pairs of points, and on that set,
what's
you,
the limit
you want to
as
find
t
the
goes to
maximum
0 from the
value
left
of this quantity is. Now, the function that
quantity,
you are
what's the
trying
limit
to,
of that?
it doesn't have to be maximized. It could be, the question
If you
could be
took
Calc 1 with
minimizing
me,
z,
you better know
but to answer that.
The correct word to say optimizing z. So optimizing, if you have a minimizing
What's
function
the limit?
minimizing problem, it means that you're trying to minimize. Why is it positive and not negative? And optimize would mean maximizing if the problem is maximizing.
When t goes to 0 from the left,
you're trying to optimize the function that you're trying to optimize. That's
t
called
goes to 0 from
an
the left, it
objective
means
function.
t is on the
So
left
this
side of
function,
0.
it means t is negative.
This function z,
so negative
it's
1
going to be
divided by
called
a negative
the
should be
objective
negative.
function.
But because the denominator is becoming 0, the
It's the
ratio will
objective
get
function.
large, right?
Again, objective function means
as
it's
you
the
divide by
quantity
smaller
or
and
the
smaller
function
number,
that you're trying
the fraction
to
gets bigger and bigger.
maximize or minimize.
So it's going to be infinity. And
these
if
variables,
the first term is going to
x1 and
infinity,
x2,
the second term is 1/3,
these are
right?
decision variables.
The whole thing is still going to go to
Decision
the whole thing is still going to go to infinity.
Variables.
Do I care about what's happening here?
Am I making sense? Or unknown? These are the unknown.
You can check
these are
if
the
you have
unknown.
extra time, but you don't have to check. Okay. Once you see that the first
that is, we are
the
trying to
quantity
determine
within the first brackets is going to infinity, you don't have to check what's happening
whenever
in the other
you have
one. Okay?
this
is
constraints
equal to,
here. These are called constraints.
I'm not even going to say equal
the
to,
first
because
three are actually
all I care to
called.
say is that I have a
the first three
divergent. I have a
are actually called
integral.
functional constraints. So let me
If it
try
was
to write it.
convergent, then I would be interested in finding the value. Okay.
Functional
Is everybody clear? Now,
constraints.
why do I not need to know what's happening? What's the second limit? Why do I not care about the second
these
limit?
two
Well,
here
notice, look at the
are
graph.
referred
We
to
are saying
as
the integral from
non-negative
-1 to 0 is already
non-negativity constraints.
divergent.
Okay,
Does it matter what's going to happen there? Together, it will be, this guy will be
constraints.
divergent, right? Okay. Questions on this problem? What I want to do the next is
everybody
go
okay?
over problems which are similar to
we are going to
your
use a couple of
homework
terms here.
problems.
So what is a feasible solution? So what's a feasible?
From section 7-8,
What is a feasible
the due date
solution?
for that homework was
Well, a feasible
the
solution
on
means
Sunday,
it's a
I'm going to change
in
that
this
to
problem. We are
Monday.
Speaking in the context of this problem,
I have two decision
problems
in my morning section, but I couldn't get
solution
there.
Means it's
and
a pair of
two problems
values of x1 and x2
homework,
for which the constraints are satisfied.
But
all the constraints are satisfied
in this section.
Any questions on this problem anymore?
Feasible solution.
Well, let's move on to the next problem.
A feasible solution is a pair of values of x1 and x2 for which all the constraints are satisfied.
So let's look at the example where I have the integral from 0
Does it satisfy all the constraints?
Tangent x dx.
Does it satisfy all the constraints?
My question is it convergent or divergent?
Can you check? Go ahead and check all the constraints
here.
They are all satisfied, right? For example, if you plug in 1, 1 in the third functional constraint, you see that you get on the left hand side 5, so which is less than 18.
The question here, is it convergent?
So it's satisfied. How about to the point 2, 2?
Which one?
Is that a feasible solution?
Actually, my question is wrong.
Well, plug in 2, 2 in every single constraint and see if
what I really wanted to ask
inequalities are satisfied.
Is this an improper integral?
Okay.
And what would be an infeasible solution? Infeasible. Is this improper? Infeasible solution.
Why not?
Can you give me an infeasible solution? Well, let's take negative 1 and
remember,
3,
what are
right?
the two types of improper integrals?
Can that
one,
be
the interval is infinite?
No, because
that's type 1. Type 2,
this point
interval is finite, but the integrand has a
right?
discontinuity somewhere in that interval.
Non-negative.
Tangent x.
And another one would be,
by now you better know that the domain of the tangent function is
7.
continuous. Is that infeasible? Between negative pi over 2 and pi over 2, but it has discontinuity at odd multiples of pi over 2.
Which constraint is violated
between 0
by
and pi over 4, it is. Another way of checking that is that you can write tangent in terms of sine and cosine.
If you plug in x2 to be 7, you get 14 on the left.
Cosine in the denominator is not 0.
And I think the third one is also...
So you know that it's defined everywhere between 0 and pi.
Wait a minute.
So I know that it's not improper.
One of them is not satisfied. So as long as one of them is not satisfied, it's an infeasible solution. Is that clear? Okay. So I don't have to worry about whether it's feasible or type 2.
Let's look at the second example.
Constraints.
Now I have the same interval, but I am integrating cotangent of x. Is that
what do I mean if I say optimal solution?
Which type?
Optimal
type 1 or type 2
solution.
Improper, and it is of type 2. I look at
because the interval is finite.
Solutions.
The integrand has a discontinuity at 0.
And I can evaluate the objective function at every feasible solution.
Cosine,
right?
Over
and
sine.
I want to find optimal solution is the point where the objective function sine 0 achieves the optimal 0 in the denominator. So the integrand has a discontinuity at the optimal solution
at the left-hand point.
Look at all the feasible solutions.
Okay? Do I know how to
evaluate the objective function at every feasible solution? So can I compute it? Well, the problem is, do I know an antiderivative of
where
the objective function achieves the optimal value?
Well, at least in Calc 1,
we didn't give you any formula for the
in this problem, it turns out there is only one optimal solution.
Okay, and we are going to see that very soon. It's in terms of the log function.
It is 2,6.
Okay. So in fact, the integral of tangent is
this terminology
of tangent is, I think, why is this called a linear programming problem?
Of cosine.
Because all the functions involved are linear functions.
So if you look at the second
objective
example,
function, that's 3x1 plus 5x2.
What's the integral from
0 to infinity of cosine squared x dx. When I reviewed what's the integral from 0 to infinity, a linear function in n variables looks like what? A linear function in n variables looks like what?
Improper integral.
A linear function. The reason I'm emphasizing that in one of the questions in your homework
looks like what?
We ask you to decide whether you have a improper integral or not.
an xn, where a1 up to an
so what's the definition of this improper integral? Well,
so that's a linear function generally.
Infinity appears at the upper limit,
so replace infinity by
left-hand side
of all the
t constraints.
Take the limit as t goes to infinity, right?
Of all the constraints are linear functions.
The right-hand sides are all cosine squared x.
Am I clear?
What should I do to compute the integral?
What is a linear programming problem is?
Maybe I can use that as
optimization problem,
where
all the involved functions are linear.
So here's here's what we should do. We should replace
functions
is
not linear.
Half 1 plus.
Instead of having x1 less than 4, let's say I have x1 squared less than 4.
Because that's what our formula
sine of x1
tells us to do,
or some other function, e to the x1, right? In that case, you have a non-linear programming problem.
This is the same as 0 to t.
So that's a totally different course.
There
are courses only on non-linear optimization problems. Okay, so our focus is on linear.
This is the limit.
So linear
as t goes to infinity. What's the integral of half?
All this terminology is making sense.
What
is an objective function? What is a decision variable? What's a functional constraint? What is a non-negative non-negativity constraint? What is a linear function?
So this is the antiderivative,
infeasible solution,
limits,
and optimal solution. Everybody agrees the integral of cosine 2x is half sine 2x.
Well, and what is that equal to?
Another terminology that we are going to use is the feasible. Is it clear that when I plug in 0, I get 0?
When I plug in 0 region, I get 0. So all I need to do is plug in t.
What would be a feasible region?
I should be getting 1/4 sine 2x.
It will be the collection of all feasible solutions. Right? It will be the collection.
Okay, as t goes to infinity, what is happening
to the quantity inside the brackets? Well, what's happening to half t as t goes to infinity?
Collection.
Half t goes to infinity. What is happening to sine 2t as t goes to infinity? Was that oscillating? Okay, so together, what's the limit? Now, in the linear programming problem that we just looked at, half t dominates the entire quantity, the functional constraints and the non-negativity constraints that we have. Does not converge to anything, right? Sine t does not converge to anything, but
don't need to be
is a bounded number.
It could be greater than 1 and 1.
So that t is going up, above, all the time. So the limit would be.
However, we will discuss later that whatever.
And so, what should I say about my
whatever inequalities that we have, we can always
integral? This is divergent.
Rewrite the constraints in terms of only less than or equal to.
Yeah, go ahead.
Okay.
Yeah.
Is that clear?
So for a moment, I'm just going to look at when we have always less than or equal to, except for the.
This is called the, maybe it's called the half-angle formula, or
I'll show you that if I have other cases, I can always convert that to this case, where I have all less than or equal to. So we are going to get there later.
But that identity will not
in
help
this problem,
you here, because
geometrically, what
if
is the feasible region?
Then I can
so I'm going to sketch the feasible region for you, okay?
But what's the difference between
so I have the x1 axis. I have the x2 axis. I am putting x2 on the vertical axis, x1 on the horizontal axis. Yeah. And
so there are many other identities that I can apply here.
But
what was the first inequality?
The appropriate one is this one.
x1 less than or equal to 4, right?
xn less than or equal to 4. Make that an equality. You get x1 is equal to x1 is
any
equal to
other
4.
Questions on that?
And that's a vertical line at 4, right?
Let me now look at this
Everybody's
integral.
okay? All right, what is the second?
What was the definition?
What is the second constraint?
Positive infinity.
2x2
negative
less than or
infinity
equal
to positive infinity. What's the
12.
definition?
Well, that's the same as x2 less than or equal to 6.
right? Yeah, so I break it up. The equation of x2 equals to 6.
Number you
That's
like.
the horizontal line at height 6.
The number 0.
Okay. So this
What's
is
the third constraint?
negative infinity to 0 sine 2x.
What's the third constraint?
Plus, remember, you have to plug in 0,
plus
so plugging in
2x2
0
is
is
less
easier
than
than
or
plugging
equal
in
to
some other
18.
number.
And I am sketching the graph of the corresponding equation, which is 3x1 plus 2x2 is equal to
2x.
I get a straight line like that.
Yes.
Is that clear?
By the way, in your homework, there is a problem.
What is the feasible region? Can someone tell me what is the feasible region here? Yeah. Right. Remember, we did integral from 0 to infinity of cosine squared.
Constraints tell me that
in your homework there is a problem where the integrand, instead of being cosine squared, it's sine squared, but there is a constant like 7.
Region has to be in the first quadrant.
Okay. But you follow exactly the same procedure. There is a homework problem that has, instead of having sine 2x,
has to be on the left side of
x1 equals to 4.
Cosine pi t.
Also, it says x2 is less than 6, so the feasible region has to be below
Still you do the same
the
thing
horizontal line at 6.
here.
And finally,
so by definition, what is that?
if you look at the 3x1 plus 2x2 equals to
negative
18 line,
infinity, right? I have to replace
if I
that
look
by a
at
parameter
what
t,
points will satisfy
and then I have to
the
take the limit
inequality 3x1 plus 2x2
as
less than
t
or equal
goes
to
to
18.
negative infinity.
Well, it's the points
0.
below the line.
sine 2x dx.
So the feasible region here
plus
would
the
be
limit as s goes to infinity, integral from 0 to s.
Remember we said
Sine,
1, 1 is a feasible
2x.
region. Is that correct? We
Yes,
said 1,
again,
2
you don't
is
have
a
to use
feasible
s and t.
region.
You can use alpha,
We said
beta,
1,
some other
7 is not.
parameter symbols if you
Right?
want.
Where is 1, 7? Right
okay,
here.
so this is the limit
We said
as t goes to negative
we said
infinity.
2, 6 is the optimal solution, right?
Antiderivative of sine
Notice that
2x
the
is
feasible
what?
region includes the boundary of the region, right? Because I have less than or equal to.
1/2.
You agree? 2, 6 we said is the
2x,
optimal solution. Again, what does that mean? It means that if I evaluate the
So I will be
objective
getting
function at
negative
every feasible solution,
cosine
every point
2x
inside
here,
the feasible region,
negative
then it
half
achieves the maximum value at
cosine
the point
2x.
2, 6.
They will be the same, right? Because I have the same
And we're
integrand.
going to see why soon. Okay? Any questions on what I just said? Is that clear? Geometrically, we see what's the
plug in, right? So I get the limit
region is. So what is the feasible region in this case? What's the
t
geometric
goes to negative
name for that?
infinity.
Plug in 0, what do you get?
Polygon, right?
It's a polygon.
If I plug in 0, cosine 0 is
okay?
1, so I get negative
I'm
half
speaking
minus,
of polygons. So generally, feasible regions should be
minus
polygons.
negative
But I'm also
half.
including
Okay,
the cases where I might
half
have an infinite
cosine
feasible,
t.
feasible. We'll see some examples.
If you want, you can combine the negative half
so
and the
that's a
negative
polygon plus f. And so
plus,
what's the general? What's the
limit as s goes to 0 from the right? Oops.
What's
This
the
is
general
infinity,
form
right?
of
This
the
is
linear
supposed to be
program?
infinity.
So let me write it this way.
Again, if I plug in s, I get negative half cosine general 2s plus a half. Okay, let me write it this way.
Okay,
That's what you're going to end up with. All right.
Generally.
So what's the limit here? What's the limit as t goes to negative infinity? And LP. What's happening here? Looks like, yeah, so what does that mean? Well,
What does that mean in terms of
I have
limit
to have
existing or
an
not existing?
objective function to optimize, right? So
You're-
let's
you're
say
right
I
there,
have
yeah.
doesn't exist, right? That's what you're trying to say, right? Does not. I have to
Does not exist,
maximize. Very good. So do I care what's happening for the second limit? Z. I
And
don't
that
care
Z
what's happening
is,
for the
let's
second
say,
limit. I'm already going to say that this is
C1
x1 plus
C2 x2 plus
when you write negative infinity to positive infinity as the sum
and
of
xn,
two
so
integrals,
x1 to
negative
xn are
infinity
the
to 0,
variables,
0 to positive
decision
infinity,
variables,
all you need
and
to show
C1
is
to
one of them
Cn,
is
they are
divergent.
just
One of them is
constants.
divergent, the whole thing is divergent.
Subject
For this to be
to
convergent, both of the
subject to
integrals on the
constraints,
right side
which
needs
we
to
can
be
write
convergent.
as a11
I could have taken the
x1
definition of negative
plus
infinity to infinity
A1
as
to
the symmetric
x2
limit. That is,
plus
I could have replaced
plus
negative t to
A1
positive
and
t, and then take the limit.
xn less
That's
than or equal to
actually
some
different.
number b1.
If I replace
Okay.
this by t, this by t, and then take the limit,
A2
that's called the
1
symmetric limit of that
x1
integral.
plus
And actually, in that case, you get a
A2
different answer.
x2
We are not taking that definition.
plus ... plus A2 and xn, which is less than or equal to b2.
All right, let's do another one.
Okay, and okay, so now ... I might have, let's say, m constraints.
so,
A
that's the homework
M1
problem there.
x1
Okay.
plus A
One of the homework problem
and
has
2 x2
integral from
plus
0 to 1 over actually 5 or actually
AM
6,
and
which is very similar to the
xn,
problem that I did 1 over actually 4.
less than or equal to
Okay.
bm.
Actually, this one is easier
Okay,
than the
so
one
these
that I
are
did.
the functional constraints.
Remember,
And
I did
also
a problem
we want
where
what? We want
Let's
x1
see.
greater than or equal to 0, x2 greater than or equal to 0.
This problem that I did, remember? Negative infinity to 1, 1
xn
over
is
root
greater
of
than or
3
equal
minus
to 0.
2x.
We'll discuss later.
What if we want some of the variables to take on some negative? There might be a similar problem in the homework.
Okay, so we'll see
And
those cases
there's
later.
another
But right now,
homework problem where
so that's the
you have
generally
something like what I have
that's
in
the
this
form
example.
of a linear.
The difference would be
program.
that instead of having x squared plus 1,
Is everybody
you might be
okay
having x
with,
squared plus 5,
what
or
I just
10, or
wrote?
12, something else. Now, what are the constants
and
here?
this is it, yeah. So that's the only difference.
All the AIJs,
How would I do this
problem? Well,
all the
once again,
BIs,
infinity
all
is
the
the upper
CIs,
limit.
they are all
So replace the
they are
upper
all
limit.
constants here, right? They are some given values. Okay.
Replace the upper limit
Is that
by
clear?
a parameter. Questions, anybody? Any questions at all? Evaluate the integral and then take the limit.
All right.
As t goes to infinity. Let's go back to our example.
Okay.
So what I want to discuss now is sort of tell you why
All right. So
the
what
objective
should that be?
function
Well,
achieves
what should
the
I do in
optimal
order to compute
solution
that integral?
at 2
Very good.
2
2x,
equals to
okay.
x squared plus 1.
Let me see. Okay.
Please go over the
So why
substitution
why do we
problems,
obtain
integration
the
by
optimal
parts
solution
over and over and over again until
optimal
it becomes your
solution
second
at
nature. And
two
not only
six.
just for this
That's
course,
the,
I mean, when you go to differential
question we are
equations,
raising.
you will be expected to know how to integrate as well. So if it becomes your second
What do you think
nature,
what I should be doing?
then,
Well,
this is what I
will
will do
do,
for you.
okay?
You'll have an excellent time. And
Let's
if you
let's look at.
forget about these things, then
Let's
difficult
look
becomes
at
very difficult. So
our-
this is du, and what is du
Our
then?
objective function.
du
Our
is
objective
2x
function is z dx,
and that is 3. And in DFQ, you will
x1
face
plus
improper
5
integrals again.
x2, right? Am I right? Let me go
Alright,
back
so
a
du
little bit
is
to
2x
see.
dx, and
3x1
so let's
plus
make that
5x2.
substitution. I get the limit. This is our objective
As
function.
t goes to infinity.
If I replace
what
z
should I
by a
take out?
specific value, or not
Let's say
take out,
z
sorry,
naught.
x dx
Then
will become
I get
what?
an equation in two
First of all,
variables,
I get a u
3x1
squared
plus
in the
5x2
denominator because of x squared
Here,
plus 1.
z0 is a specific
And then
value.
x and dx, right? We are going to call
Together
them
becomes
the level
half du, right?
the level set. And what will be the
Or
limits
level
of integration
of
level curve set of z?
sorry, let me rewrite
At
that
z0.
here. Okay. I had an
At
x and a dx. Yeah, so limits of integration. So when x is 0, what we are going to do is start when looking at t, I get u to be t squared values of z, possible values of z, and then I can say the corresponding this is equal to the limit. Okay. For example, let's t goes to infinity. We're trying to optimize z, right? So let's say, well, by the way, before I let's start with the value 0. Do you expect this to be a convergent, let's start with the value 0 for z and see if we can improve that value. Expect this to be divergent? Why? Okay. So I'm going to plug in 0. One thing I want you to notice though, if you look at for any z0,
go back to the original.
No matter what z0 is, if you look at the level set, the equation, the graph of that is a what?
Should this be convergent or divergent? Do you have any intuition?
For any given z0, the graph is a?
Why?
What's that? Z0 equals to 3x1 plus 5x2. The equation. I'm looking at the graph of the equation.
I didn't have that square.
It's a line, right?
Did you still
now, no matter what z0 is, what are the slopes?
Okay,
are
so
they the
what
same?
I'm going to say is that one,
for example, if z0 is 10 and z0 is 20,
it doesn't really matter.
I get two lines, right?
Because
do they have the same slopes?
That one really doesn't matter.
Well, the slope is determined by what?
You have what? X over?
The coefficients of x1 and x2, right?
Would you agree with that? 1 over x cubed? Remember the integral of 1 over x squared was?
So if I change the z0, it doesn't change the slope. It does change the line, but it doesn't change the slope. That means for all the values of z0, I get parallel lines, right? You agree with that? Okay, is that making sense? So let's look at when z0 is 0. If I take z0 to be 0, idea that it's going to be then convergent. I get, let's see if that's the case. I have half equation. Integral 5x2 right? From 1 to t squared, and what would be the graph? What would be the graph of that? And also at the same time, let me write. I also want to look at when z0 is 10. Somebody please tell me what's the. Then I'm going to get this equation. What's the antiderivative plus 5x2? Okay. Well, how would I know if z can take on the value 10? How would I know that? What's the antiderivative? How would I know that z takes on the value 10 somewhere? How would I know that? Of course, there are points where z takes on the value. And there are points in the plane where z takes on the value 0, of course. As t goes in fact, to z takes on the value 10 at every single point on the line, right? So I basically took out that negative. But how would I know that there is a feasible point where z takes on the value 10? How do I check that? How do I check there is a feasible point where z takes on the value 10? In my head, I first took out that negative. If I look at the graph of this equation, right, 10 equals to this. Now, as it gives me to infinity, all the points where the value of z is 10, right, of this guy. What I'm asking, all those points may not be feasible, right? But I'm saying, how do I know there will be a point? How do I check? There is a point, feasible point, where z takes on the value 10. And so, what would be the limit? See if it intersects the feasible region, right? Negative half times. The intersection of the line with the feasible region would be the feasible points where z is 10, so right? My integral, again, intersection of the line with the feasible region gives you the feasible points where the value of z is half. Is everybody okay? So let's draw that. Is everybody okay with what I just said? I guess so. Let's say this very quickly. Another problem similar to the homework. Yeah, it's more like this. Let's say I have the integral form. Okay, so this is this one that I just drew. That's where z is 10. 1 to 2. This is where 5 is divided by root of 2 minus x. Properly there, I guess. Dx. This is where z is 10. So is it improper? The part of the line that is inside the feasible region gives you at the upper limit points, the upper limit points where the value of z, the objective function is 10. And when z is 0, which line do I get? Well, I get a line parallel to that, right? So it will
as
basically
t
be a
goes to
line
that upper limit from right or left,
which would be, well, that's not a good line, I guess. Let me delete that.
So you want t to be smaller than 2, right? You want t to be smaller than 2.
Let me just go
You gotta
from
go
here.
from the left.
It will be a line that is parallel to that.
Remember,
And so
all
what's
changes. What do I have to do? How do I know it goes to the origin?
Yeah.
Well, if you look at the equation, 0 equals to 3x1 plus 5x2,
So how would I
x1 equals to
solve
0, x2 equals to 0
evaluate
is
the
the
integral?
point.
Right? So I know that it goes through the origin when z is 0.
Do I have to use a u substitution? I have that 5 really doesn't matter, right? I have 1 over root of 2 minus x.
Okay, so
If
this
2
is
minus
the
x
this is the
were
line
just
where
x,
z
I'm
is
happy,
0,
right? So replace 2 minus x
is 0.
by u. Okay.
So
when z
replace,
is 10, I get that point. What if
2
z is
minus
20?
x by u? What if z is 20? So then du would be negative dx. So if I do that, I get,
If z is 20, what line I get? Well,
5
I can draw that for you.
over root of u.
You can check that.
And then
if z is 10,
what is dx? I basically get, negative du, yes. This
before I move
line.
on, what would be the limits of integration? If
Is
x
that
is
parallel
1,
enough?
if x is 1, then u is
better.
1, right?
Okay.
So if x
So
is t,
this is where z is 20.
u is 2 minus t.
Are we okay?
And I claim,
All right, so this
the
is going to
better,
be
the bigger the value of z is, the higher the corresponding level set is.
Am I making sense?
The bigger the value of z is, the bigger the value of z naught is, the higher it's not going to change the
corresponding
problem
level set,
divergent,
the
but
corresponding line.
This conversion, the value will be changed.
Is that making sense?
So
you can also verify
if you don't
that
want to
by
change the
looking
limits of
at-
integration,
Remember z naught,
you can
if I
find
take
the
z naught to be
derivative and go back to x, and then
3x1
use
plus
the
5x2, and then I
same
plug
limits of
in 0,
integration.
10
in
and
any
20
case,
for that.
but I think it's
notice
better
that,
to just
change the limits
I
of
can-
integration. So
I
I can
go
solve for
from
basically
1 to
5x2
2
minus t, 1
be
over root of u. 5x2 would be z naught
and
minus 3x1,
anyone
right?
remembers the
And what is
antiderivative? The bigger the value of z naught is, the bigger the value of x2 would be, right?
Am I making sense?
For
1 over root of u.
for a fixed x1, the bigger the z naught, the bigger the
What's the
x2 value. That
antiderivative?
tells
1 over
you
u was
the level set,
root of u.
the line
Very
corresponding
good.
to
So this is
10 would
going
be
to be the
lower
limit
than, will lie
as t
below
goes to
the line corresponding
negative 2
to
from
z
the
naught
left.
equals to 20.
Negative 5,
Right?
Actually, let's write
If
negative
that's clear,
10, right?
Let's see how we can
do that.
find
And
the
then
optimal
I'm
factoring out
solution.
that 2. So once I factor
This is
out
how
the
we can
2,
find
then I'm
the
going to plug
optimal
in
solution.
Notice
I'm
that
going to get root
I
of
can
2
start
minus
with
t,
the level set z naught equals to 0.
I
I look at the level set corresponding to the objective function value equals to 0.
What am I getting then? What's the limit?
And then whatever that level set is, the line,
What's the limit
I
of
start
this as
moving
t
it
goes to 2?
in the direction of increasing
From the
value
left,
of
right?
z.
On the left.
So if
Obviously
I
zero,
move
right?
that line at z equals to 0, the line, the level set
So what am
corresponding
I
to z
getting?
equals to 0, whatever that line is, should I move it below? No, I should move it
All right.
upward.
So unfortunately,
in a parallel fashion,
white paper.
okay? Because
your
that's
quiz.
the direction of increasing
The quiz
value of z.
question will be
Am I making sense? The larger the
following.
value of z is, or z naught is, the higher the corresponding level set will lie, right? You guys agree with that? So I should move my z equals to 0 level set in the direction of increasing value of z. So think about
your
this.
homework
I
that's
keep
due
increasing the
on,
value.
Sunday
I
will
keep
be the due
moving
date will be
my
moved
level
to
set
Monday.
in this
So there are
in this
two
direction,
problems
right?
that I think you may not be able to
And
do,
as I
so
move it,
you should start doing it.
as long
and
as it
on Monday
intersects
after
the
I
as long
talk
as
about
it intersects
those two
the
problems, you can
feasible
finish up.
region, I am getting feasible solutions, right? Now keep moving it until you cannot move further. That is,
keep moving it in the direction of increasing value of z until you moving further takes you away from the feasible region, outside the feasible region, right? So move the level set for z equals to 0 in the direction of increasing value of z until moving further takes the level set outside the feasible region. Okay? In this case, if you look at the point 26, notice that where is my, okay, so if I look at here, if you plug in 2 for x1 and 6 for x2, what value do you get? 36. And in fact, you are achieving that 36 right there. So I can, if you think about it, I can move it until I get to that point 26. Okay, at some point I'm going to get to that point 26. Let's see if that is parallel enough. Maybe let me do it this way. Okay. So you get, I guess, hopefully you understand that what I did. So if I keep moving this level set until I can, you'll see that it goes up to 2.6. It gets up to 2.6, and if I try to move it beyond that, it goes out of the feasible region. Okay, and it's going to achieve the largest value of the objective function at that point. So what's the this is the level set corresponding to z equals to what? If you look at this equation here, for replace x1 by 2, x2 by 6, you get 36. Okay? Is that making sense? And so that's how geometrically I know that the optimal solution of that, remember I said the optimal solution was 2.6, and geometrically I know how that works, why that's the case. Okay? Is everybody okay with that? Now, okay, it's nice that I could do this geometrically, but I can only do it geometrically for in the case I have 2 decision variables. If I have 3, maybe I could do this in sometimes, but you can think about 3-dimensional, it's going to be pretty hard. And of course, if it is 4 variables, then okay, forget about doing it geometrically, right? However, understanding how this works geometrically, it's important because it's telling you something important, which is you're considering the level sets. So you're starting with the value of z equals to 0. You're trying to optimize z, and you're saying, well, let's start with the value of z to be 0 and think about, can I improve it? Okay? Well, the answer is yes. It seems like I can improve it. Improving it means that that level set is being moved through the feasible region in the direction of increasing values of z. And I keep moving it until moving further would mean that I go outside of the feasible region. And that point where I cannot move any further, at that point, I am going to end up with the optimal solution. Okay? Okay, so we are out of time, so I'm going to move from this point next time, okay? So from now on, you should expect having homeworks online on these topics, okay?